Let's find the zeros of linear functions. Linear functions are functions whose graph is a line, which is the same thing as finding the x-intercepts. So when we do find the zero tells you everything that you need to know. We're just going to set the equation or the function equal to 0 and solve for the variable. So let's do a couple of examples. F of x equals x minus 9. So what I want to do is set x minus 9 equal to 0 and solve for x by isolating x by eliminating the minus 9 by adding 9 to both sides. When we do that, we get x equals 9. So that's the 0. X equals 9 is a 0. Now the y-intercept would be 9, 0 because the intercept is a point on the x-axis. So that's the x-intercept. If I misspoke and said y, I meant x-intercept. Now what we can do, we can actually look at the graph on the calculator. I'm using TI-83. So let's go to y equals and type in x minus 9. F of x is the same as y, in case you're wondering. Hit graph. You can see it looks like it's crossing at 9. One way to verify that is with the table. The table doesn't always work, but in this case it will, because it's a nice integer, 9, 0, which we have right here. Another thing we can do is go to second trace, which is a calculate button, and you actually see a 0 feature. So click on 2. Left bound, I can just, what that means is I'm looking at where it's crossing the x-axis and I let it be any point to the left of it. I might want to move it just to make it a little bit more easier to identify where we're at. As long as I'm to the left of it, I can hit enter. Right bound, I can move my arrow. I can only use my left and right arrows. Or I can just type in an x value to the right where I think it's crossing. So if I think it's crossing at 9, I can use an x value to the right, which is 10. I don't think it will let me do 11 because that's outside the window range. Hit enter. As long as it doesn't give me an error, I'm good to go. So when it says guess, hit enter. You can see on the bottom, 0 is 9, 0. And there's something else that I think is a whole lot easier. So let's go back to y equals. Let's hit enter this time. So we go down to y2. Type in 0, because when I hit graph, it's actually graphing the x-axis. So I actually have two lines being graphed, x minus 9 and then the x-axis. So when I hit second trace, I can now use the intersect feature, which is number 5. And I don't actually have to move. The only time I need to move if there were more than one 0, but here I don't have to, so I just hit enter 3 times. And intersection gives us 9, 0. So you may want to play around with your calculator a little bit. B part, to solve B part, is find 0. So we're going to take the x over 4 plus 7, set that equal to 0. We're going to isolate the x term by getting rid of the plus 7 by subtracting 7. So we have x over 4 equals negative 7. I probably need to erase this because I don't want to confuse anybody. Let's make it a little bit easier to see. Equals negative 7. And then let's multiply by 4 to eliminate the 4 since it's being divided. 4's cancel over here, leaving the x. And then negative 7 times 4 is negative 28. So that's the actual 0. If we wanted the x-intercept, it would be negative 28, 0. So what you want will be determining what you're being asked. So here's an example where we're already given the graph. So we're going to find the 0 and the x-intercept. First thing we may want to do is go ahead and find the x-intercept. So we're going to count where it's crossing the x-axis. Did you get it? X-intercept, x-axis. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like it's crossing at negative 8, 0. That's the x-intercept. Which means that the 0 is going to be x equals negative 8. And that's it.